Hello again. Here we are going to make an attempt in solving for the result of this complicated set of operations. We are going to solve for the union of whatever would be the complement of the intersection of sets L and M together with our K. Notice later how this task would result to this process. This is all about sets. Hello, welcome to another video. Here we are going to solve for the union of set K and the result when we take the complement of the intersection of sets L and M. You might notice that this item might be too complicated because it involves three different set operations. We have the union, the intersection, and the complement. But to solve for this, we just need to properly consider which operations to be solved first. In this case, we are going to look first on our grouping symbol. We will just be leaving K for our last step. Now our grouping symbol is the set complement of the intersection of sets L and M. And among the two, or between the two operations, we shall start first with this operation. So we will get first the intersection of sets L and M. To do that, we just need to look at the common elements, because if you say L intersection with M, it talks about the element or elements that can be found in both sets L and M. For intersection talks about the elements that can be found in both sets. Looking at the sets L and M here, we could say that only elements I and L can be found in both sets. In this case, the intersection of sets L and M is a set containing those two elements, I and L. Now that we are done with the first set operation, we just need to subject it now to a complement. When you say complement or set complement, we will refer it to a universal set on the given problem. The universal set here is given here at the top, which is a set of X, such that X is a letter in the word family. To do this, let's start writing this first in its roster form. And again, the universal set is a set containing the letters in the word family, so this should include letters F, A, M, letter I, L, and Y. This is for the universal set. We will be using this to get the complement of the result when we take the intersection of sets L and M as presented here, because the complement is only referring to elements of the universal set minus or less the elements of the operation or the result of set operations involving the complement. In short, to get the complement of the intersection of sets L and M, we just need to remove the elements I and L from this universal set. We have this one here and this. So these are the two elements that can be removed from our universal set, which will result the complement of this set operation. So you will have elements F, A, M, and then Y. These are the elements for the complement of the intersection of sets L and M. This is now to be subjected to our last set operation, which is union. So when we say this result union with set K, we just simply need to list down all elements from this result and set K. Notice that set K there is already set with elements F, A, and M, so we are going to include that later. Let's start with this result. Given here, you have your elements F, A, M, and then Y. Then we write the elements of set K, but when you check this one, you are going to note again the elements F, but when you write it here, notice that it's already a duplication of your letter F here, already an element. Take note that a set is a collection of unique objects, so we don't need to write it. So we remove the second F. This is also true with the reappearance of A and M, and we will not be writing them as well. In short, this is the final result for this entire operation. Whether or not you're a student who likes math, a student who wishes to understand math, or a student who loves math tasks, you all have something in common. And that commonality could make you as our next subscriber. Subscribe now.